We're going to be talking about tracing, observability, and AI in agentic systems today. I'm your host, Ed Charbonneau. I'm a principal developer here at Progress Software, and I am joined by Lubo Atanasov, the senior product manager on the observability platform. We're going to start off by talking a little bit about the application engineering lifecycle when we're talking about agentic apps. And a lot of this reminds me of um, the the testing cycle for software development, like the test-driven development cycle, where you have your red, green refactor mode. When you're working with AI apps, you're going to build, evaluate, and optimize. So when you're in the build phase, you're rapid prototyping, you're writing a lot of prompts, and then you're kind of changing those prompts to see if you can get the agent to do the activity that you want it to do. And it's all that natural language type of development where you're forming that prompt and trying to get it to clearly do what you want it to do. And then you kind of step into the evaluation phase where you're trying to get that non-deterministic behavior to kind of behave a little bit better. These large language models can tend to step outside of what their prompts are telling them to do, and you need to go back and adjust the prompt as needed. And you may be adding multiple agents to your workflow and chaining those together. And things like retrieval-augmented generation, where you're off searching for data and pulling that into your agents. Start adding that type of behavior in, and you might start to notice that tools are failing and you're not retrieving the right documents, or maybe one of your agents in the workflow isn't responding the way you are or way you'd like it to be. These things are kind of difficult to debug, but you move on and you fine tune those prompts, get them. You might compare different models and get things working the way you want to, but without some sort of uh, tooling that is giving you logging and feedback on this workflow, you kind of have to guess at what you're doing. That's one of the things that we're going to try to address today, is that pain point. That's where the observability gap lies. Agentic applications are quickly moving into production. We saw a lot of people in the poll here say that they're learning, but there was also a pretty good portion of people that were actively building things, and some had deployed to production. This number is just going to keep growing. Like all the folks that are learning today, I'm sure you're going to go start, putting down some lines of code and getting things towards production. So teams are having to really operate quickly on this stuff. And traditional tools that are built for measuring success, um, they work here, but they often can give you a false sense of security. So things like logging in APM, they might give you a status code that says that the service is working correctly, but there might be some underlying things that you might not see that those tools aren't surfacing. So things like the model doing internal reasoning, taking extra long time to do the task. Maybe the prompt is overly engineered, or causing it to burn excessive tokens, or it's not calling the right tools. Those are all things that your APM systems might not be surfacing that you can see. And that's where the strategy really shifts when it comes to the observability portion of AI engineering. We really need to know about the behavior. Did the agent actually do what the prompt told it to do? Did it give us the output that we expected? And can we track over time that that output is consistent? Also, as I talked about on the intro, the costs are changing daily here. We keep seeing news from, like Claude, Microsoft, and the other vendors that they are increasing token prices. So it's really important to see how your spending is adding up and identify places where you can go in and fine tune your agents so they can continue to do the task and stay on task, but do it at a lesser expense. And then, quality is a huge aspect of this here as well. Is the output what you intended the output to be? How do you evaluate those things? How do you run evaluations? and what types of tools do you use to support that behavior? Lubo, maybe you could tell us a little bit more about deterministic and agentic AI systems and kind of the key differences between working in these environments.
Thanks, Ed, and I hope that you guys can see my screen already, right?
Yep, looks good.
That's good. Amazing. I didn't leak any API keys or anything yet, so that's a good thing. So you briefly touched upon the agent observability gap, but let me try and make this a little bit more concrete. On the left side of the screen, we have a traditional deterministic app. This is what all of us have been developing for the past 20 years and so. A request comes in, it hits a service, a response goes out. Same input always gives you the same output. The whole path is fixed. You know what could break, you know why it breaks. And honestly, traditional APM tooling is already great at detecting such failures. On the right side is where things get a little bit more interesting. A user request comes in, but now it hits the LLM. And the LLM decides what to do next. Maybe it goes to retrieval. Maybe it goes to two. Maybe it goes to tools. Maybe it doesn't like the answer and it tries itself. It can just keep whooping and whooping until the model decides it's done. That word decides is kind of the whole thing. The model is the one making decisions at runtime and not the code that we as developers wrote. If you run the same request twice, you might get two completely different execution paths. From the outside, this still looks like a normal API call, but inside it's a totally different animal. And that's the gap everything else today comes back to. We figure out how to change slides, that's good. So how does this actually feel like in practice? And this is really the slide that I want to remain in your heads after the webinar. In a playground, in a demo environment, in a prototype, AI looks amazing, almost like magic. You type a prompt, the model gives you an answer. Job well done. Success always just looks like success. This is exactly the demos and prototypes vendors show to your CEO when they try to sell him an AI agent. But take that exact same AI agent, run it in a production environment, and look what happens. So remember how the model is the one which decides what to do. A request comes in, retrieval fires, and quietly pulls a stale chunk of data. The first two search returns 200, all good. The second two upgrade also returns 200, except it's a silent 200. The thing didn't actually happen, but HTTP has no idea about that. Then the LM reasoning step kicks in, and it drags out to 9 seconds or 8.5 seconds or whatever. As a result, this single request costs you $50. And the final answer that was given back to the user drifted away from what the user actually wanted. If we were to use traditional APM software to monitor this agent, we would have all those failures and 0 errors logged in the system. Nothing turned red, the dashboard is green. The first person who is going to notice something is wrong is your user, your customers. That's the problem. So now the fair question at this point is, I already pay for Datadog or for Splunk or for any other traditional APM software. Why do I need something else? Why I need to buy something else? And honestly, those tools are excellent for what they were built for. They were just not built to monitor AI agents. Traditional APM was made for stateless HTTP. It sees requests, it sees the response, it sees your CPU, it sees your memory. That's however maybe only 20% of an actual agent run. The rest, the reasoning, the tool decisions, the stuff that actually broke are invisible to it. If you were to add some more advanced logging, this gets you a little bit further, call it 50%. But you will only see whatever you as a developer remember to log. But you still don't get the causal chain between steps, you don't get the actual prompts, the completions, you don't see what each step costs, and you definitely cannot catch hallucinations. Agent observability platforms this is what we built, are designed for what an agent actually is, a stateful graph. So you get the full span tree, parent and child, every prompt and completion, token cost on every single step, evaluation scores, and most platforms support even more. What? You're what? You're pushing 110 years old, right? So you have been in software development for quite a while already. Have you
I've been
been
around.
playing with APM and AI agents?
Just a little bit. So there's some tools that are usually built in. I'll show one of them today, DevUI, and then there's things like Aspire. But usually those are short-lived sessions, so you don't get to see things over a long period of time.
Okay. And those tools are great, right? It's just that AI observability answers a different question. Is the AI behaving correctly? Are the decisions good? Is the output grounded? Is it hallucinating? Is the user getting what they needed? If you're running agents in production today and you only have the left column, traditional APM, I would encourage you to look closer at what your users are actually experiencing, because there is a real chance you don't know.
So I'm going to start with something called DevUI. DevUI is a beta tool from Microsoft, and it is part of Microsoft Agent Framework. Microsoft Agent Framework is in full generally available release now, and the DevUI tool is just an extra tool that you can use for a short development loop. Unfortunately, it is in beta. A lot of these AI tools are very new, and everybody's learning and moving together at the same time. And if you look at the C# side of the documentation here, it's pretty much coming soon. So there's going to be some features that aren't quite ready, but it's a really neat tool and cool way to get started. So we're going to take a look at it. And Python is available as well. If you're doing any Python, you actually have full documentation on how to get started with DevUI and Agent Framework on the Python side. So we're going to dive into the C# version of this today. You can grab the DevUI bits at NuGet. If you search for AI agents and filter by templates, you'll see this Microsoft Agent AI templates package. This is going to get you the project that I'm about to show. So if you install that project template and run it, this is the application that you get. So I have scaffolded this out so we don't have to watch that happen in real time. But this is essentially an ASP.NET application running on .NET 10. And it comes with Microsoft Agent Framework installed already. And then it has this little bit here called DevUI. And in this pipeline, we are going to add some AI agents with Microsoft Agent Framework. And these are called hosted agents. They get attached right to ASP.NET with this add AI agent builder. So we can call add AI agent, and this one is going to be a writer, and its responsibility is to write short stories based on a topic. The next agent is an editor, and this editor takes a story and then edits it to improve the grammar and style of that story. And then I also have an add workflow um, agent builder here. And this is going to give me a hosted workflow called Publisher, and it contains a writer and editor agent that hand off to each other. So the workflow is that I give it a topic, the writer writes about that topic and hands that written copy off to the editor makes its edits, and then returns that as the output of the workflow. And all of this is just in a program CS file, and it gets surfaced through this map dev UI. So I'm going to run this with .NET Run. And when it runs, I should be able to launch this application in the browser and then navigate to the dev UI address. So it's spinning up here, and hopefully Azure works with us today. There was some latency issues with Azure, which I'll explain. in the end of the demo here, where we were trying to make calls in a dry run of this yesterday, and it just didn't want to cooperate. But we were able to capture all of that through observability to see those happening in our traces. So here's my browser within Visual Studio Code, and I'm going to say DevUI in the URL. Once I have DevUI up and running, essentially what happens is it takes all of the registered agents in the application and puts them in this user interface where I can interact with them. So I don't have to go out and build a chat user interface. I can just rely on DevUI to provide that for me, and I can tinker with my agents here. So I'm going to go to the writer agent, and I'm going to ask it, it just needs a topic. So it's kind of like improv, I suppose. We can just say technology, and it is going to write about technology. And it's going to spin on that for a minute. I have streaming responses disabled because in the current build of DevUI, streaming responses will give you no output on certain workflows that are surfaced in here. So again, it is a beta. There are some caveats to using this. But I did get my response back, and you can see that I have a little bit of trace information here. I have the event that occurred and how many tokens it used, and the input, the output, and the response ID. Didn't really tell me how long this took. It did give me a time stamp. The traces and tools are not enabled in this build, so those are only available in Python right now. So we can't dive into too much tooling, but that's okay. I'll show you how to do that in just a moment. I'm also going to run the publisher workflow. So this one has the writer and the editor, and they will run in series with each other. So I can add another topic here. I'll say food, and we'll run that workflow. And this is going to go through the writer, pass it off to the editor, and then give me a completed work. And that might take a couple seconds to run. While it does that, I'm going to change up. There we go. There's our completed workflow. So again, total tokens is displayed. The output is here. And this gives me a nice internal loop that I can work with when I'm developing my agents. So I can go back and change prompts. I can reload the entire application, select my my agent and rerun some samples in here and get an output to see what those responses look like. So I'm going to go to a different branch where I have observability added. And we'll take a look at what this experience is like when we add observability. So same application, I've just added some new bits here. I've added the progress observability extensions for AI here. And I'm going to configure and set up the observability with some options. So I've got a new observability options, and on the app name, I'm just going to use the application name. And on additional tags, I want to point this out because this is a nice feature that we can use to identify traces in our platform. And I'm going to set this to the environment name. So this environment name is going to come back as production, development, or staging. And that's going to allow me to filter between the different traces in my system, so I can look at traces that are just in development, or I can narrow that down to ones that are in production. I can also add additional tags on here, maybe some versioning, or just additional things that I want to look at or filter by. So I'm going to initialize that observability tracer, and then I just add it into my pipeline. So I have my iChat client. I'm going to say, go ahead and add observability using those options I set. And then on any tool calls that I have, if I want to trace those, I'm just going to do the same thing, say add tool observability on my tool collection. So now I have observability set up. I'm going to run this application again with the new bits that are added. And what we'll see is, in addition to DevUI, that gives me that internal quick response for my dev loop. We'll go to the publisher workflow again, and we're going to say, give me one on gaming. Give me a story about gaming, and that's going to run. And we'll let that complete, and then we'll jump into the browser and see what kind of responses and traces that we got from this workflow. So there's our workflow completed. We can say we spent 3,034 tokens, and that's about all the information I have here. But if I go over to my observability dashboard, I'm going to refresh this so I got the latest traces. This is my agent that I just ran and all of the information that went through that agent. So you can see I can drill down into this, and my input here was gaming, and it generated this story about gaming and sent that through a tool in that pipeline, and then it was edited by the editor, and then the final output has the title and everything with the editor's tweaks in that copy. So it went through the full cycle of inputs and outputs. And there's 4 spans of activity there, and it tells me the tokens for all of this, and also the cost for running that workflow. What's nice about this is outside of that internal dev loop. So I can continue to work in here and reboot this internal server as much as I want, change my prompts, change models, and evaluate in here. And then I have an ongoing history inside of my observability platform where I can go session to session and compare things across different spans from different runs. I can compare different models, and I can also filter if I were to set some tags up in here for different models or different environments. For example, I could say this is my development environment, and I can filter on that, and you're not going to see it change because these are all in the development mode, which we can see in our tags column here. So these are all development related spans. So this gives me that external loop that I can dig into. So I have my quick internal loop with DevUI and my long-term storage on the observability side. And we can take this one more step further. And I'm going to add some additional tools to my DevUI here. So I've got some new agents this time. I have one that can do some cost estimating, and I have this playwright summarizing agent that's fun to use. It can open a browser and do some web scraping and things like that. So we'll say .NET run again and reboot our server with these new changes in it, and we should see some new agents in our environment now. So I'll open this up here to DevUI, and we'll grab the playwright agent. And the playwright agent can summarize web pages. So I can tell it to go to www.telerik.com and summarize what's going on our web page there. And this is going to load a browser internally, go out to the web page, scrape the data from it, do a summary, and then give me a response back. And it gave me a nice summary there. I'm also going to give a new conversation here, and let's do about blank. And I'm going to do this on purpose because I'm giving it a web page it essentially can't summarize. And it says that the about blank page is typically displayed by web browsers, contains no content layout, and it serves as a placeholder. So there's a reason I did that. I wanted to show what that looks like in observability. And we'll come in here and we'll look at the first iteration of this where I asked the agent to go to telerik.com and run the playwright tooling. Here I can see the tool executed and it's navigating to the web page. And then it gave me an output of a summary of that web page. But what happened when I gave it the agent to go out to the about page? Well, I'm going to click on the final result here. I can see the input was about blank, and the output is a summary technically, and it is a status code of success, but is this the response that I'm looking for. So this is something that Lubo can expand a little bit more upon with evaluations and evaluators, where I can identify things that may have a status code of success, but the output really isn't the results that I'm looking for. And I could use evaluators and do evaluations to identify where agents are running, but they're not doing anything meaningful, or they have an error state, or they're just plain old burning out tokens for no good reason.
We saw that AI agents can break, but what are some realistic typical scenarios, common scenarios that we have seen across our customers and scenarios that we have experienced internally? What I want to demo you today is 3 very common scenarios. Most of you have heard about prompt injections, so I want to show you how you can observe whether your agent is potentially someone is trying to hack it. And I also want to show you how you can detect, for example, when your agent called the wrong tool. And I want to show you how you can also detect hallucinations coming from the large model. When I'm showing you those demos, it's important to keep in the back of our hands that platforms like ours, they're not just used to passively observe the data that's coming there, but it's a tool which can help you evaluate the quality of the agent and thus help you improve it in the next iteration. So let me go and start with the actual demos now. I have prepared a demo agent. My demo agent, it's a support agent. If you have been part of the AI transformation, chances are at some point in your company, someone decided or starts the discussion on, hey, can we kind of automate our support ticketing system, right? It's one of the most common scenarios that we have seen out there. Support agents are great. They can help you find information for a specific user. They can, for example, get more information for an order that your customers made, or they can search through tons of tickets that are stored in your internal support system. How does an agent like this one works? So if I were to run this agent at the moment, and that's just a visual representation, an agent would receive a user question, an inquiry. It would go through the tools that it identifies as necessary for the specific scenario and return a final replay to the end customer, to the user. So this thing looked like something simple on screen, but in the background, every single one of those steps produced a span, a trace inside our platform. If we were to go to our observability platform, you'd be able to see that there is a session recorded from a few seconds ago, and you can see the whole execution trace of this agent. You can see what the input to the LM was. You can see the final output that the agent provided. And you can also see all tools that have been called during that agentic loop execution. Oh, great. So the agent that I'm using is built in .NET, using the Microsoft Agents AI framework and Microsoft Extensions AI SDK. In order for me to start receiving those traces inside our platform, I have also instrumented it with our Progress Observability SDK. The agent that you see on screen is vibe coded, right? So I'm a product manager. I'm no longer a professional developer. So I vibe code a lot. So what could go wrong when your product manager vibe codes a support agents and run it in production? That's what we are going to explore now. In order for me to show you some realistic scenarios, I have vibe coded a control plane which executes specific scenarios to this AI agent. So for example, I'm going to mimic a user agent conversation, which is going to lead to a prompt injection. This is the first scenario that I want to show you guys. So if anyone hasn't heard about prompt injections or indirect prompt injections, indirect prompt injections are a security vulnerability where a hacker tries to inject a malicious payload somewhere in an external data source, which is then going to serve as context for the large language model to work with. So for example, we're talking about a support ticketing system. Maybe one of my customers wanted to try and exploit my system, and he added somewhere in the comments of the support tickets some malicious scripts. So for example, he said something like, he instructed the large language model to always include a phishing URL. If my agent would go to that support ticket, use that information, and I couldn't pick up the prompt injection and prevent it, this phishing URL would end up being shown to my customer, which of course can lead to some real issues. So let me just run this scenario, and I will show you, first of all, how does this specific trace scenario looks like in our platform. And hopefully it works. Hopefully it works. It's a live demo. Nothing is mocked. And all of your demos worked. I was surprised.
So you got your own chaos monkey going on here.
I do.
What's the stack here that you use to build this this tool for running these agents and then so you can observe them?
It's the worst stack one can get. It's vibe coded with pure JavaScript and pure HTML, and whoever knows what else did my coding agent picked up from the internet.
It was let the agent decide stack. Is that what you're telling me?
Who cares about stack ads, right? When you can vibe code stuff and push them in production, awesome. It all just works.
Well, it looks like your evaluation ran.
It looks like the whole thing ran, yes. Let's see what it actually got recorded inside our observability platform. And trust me, guys, our observability platform is not vibe coded by me. We actually have real engineers who know how to write code and know how to do it in a secure manner. So the specific trace now led to this execution trace. So you can see again that the input to the agent was something like, I have a few Safari login tickets to look at, pull the recent ones for me, and summarize the top issues customers are reporting. And the output looks a little bit fishy, right? So it seems that the agent is giving some information for the recent 3 tickets, but it seems there is also a very urgent URL, which is asking me to verify my Contoso. I hope it's a fictional company because it's again coming from the vibe coder on a specific URL. This screams to me as a person, this looks a little bit fishy. Maybe something went wrong. So maybe
you mean fishy with a PH, right?
Yeah, for sure. The other phishing is completely fine. Let's go through it. So, okay. What I can do as a human being is either go through every single one of those traces and manually look for such outputs, which look a little bit strange, right? And record them somewhere in an Excel file and then say, hey, those are wrong. However, a typical support agent would receive thousands of requests every single day. I don't have the time to do that. That's why in our product, in our platform, we have built the concept of evaluation tasks, and Ed briefly touched upon it. Evaluation tasks are something which allows you to evaluate the output of your agents based on predefined criteria. So for this specific example, I can write an evaluator which identifies potentially malicious outputs which might be coming from a prompt injection. So this evaluation task that you see on screen, we can either run it real time on every single trace that's coming inside our platform, or we can run it historically on data that's already being stored in our platform. So if I wanted to, I could review, let's say, the data for the past 2 months and try to detect prompt injections there. If I wanted to, I could set up a real-time evaluation task, which detects such prompt injections and receive a notification when something was detected or not. So what was detected, right? I ran an actual trace which appeared to have a prompt injection. If we were to go to our scores, you would see that there is an evaluator name called prompt injection customer support and the score compromised. That probably means that something went wrong. If I wanted to see what exactly was compromised, I could open the, sorry, I'm clicking too fast, the related to this specific evaluation span and see exactly what yielded this compromised result. If I were to look into the evaluation stat, I would see the score and an explanation why did the evaluator decided that this is a prompt injection or not. This is just very helpful for you guys to start using once you roll out those AI agents in production, because what happens nowadays is that everyone are just trying to exploit them. Do you want to open one small or a large bracket here that at the moment you are trying to detect prompt injection attempts, but we are not preventing them. Preventing prompt injections is a completely different field, which is usually managed with guardrails and so on. Even if you were to implement a guardrail, which tries to actually prevent this prompt injection, you would still want to collect the traces and evaluate them to ensure that the guardrail you have implemented works as it's intended to be. So that was the first demo that I wanted to show, and I can see that we're moving a little bit fast with time, so let me just go straight to the next one. The next demo that I wanted to do is a bit personal to me. So when I started building AI agents, right, when the whole hype happened like a year and a half ago already, I was trying to use LangChain. I was building an agent with LangChain, and I was trying to make it call the tool that I wanted to call. So tools are something like, what is the agent capable to do? So is the agent capable to retrieve more information from a database? Is the agent capable to, let's say, execute a function? Is the agent capable to call an API and get info from there? The issue is that, as we already determined, LLMs tend to do whatever they want to, and sometimes they would call the wrong tool. In an actual production environment, this can be really bad, and that's what I want to demo to you. So if I were to run this scenario, it's just, again, running the same Microsoft extensions AI agent that I showed you guys. It's just something visual so that we have something on screen. I would expect that I now have a new trace from my agent, so from a few seconds ago, which is just showing me what the agent did. I can again manually look into the agent2 trace span, and if I were to carefully read that, I would notice that a tool called findUser was executed, but the result of this tool looks a little bit odd. It seems like it's returning a response deleted, true, user ID, user billing. So it's a bit odd for me as a person to see that I was looking for a user, but something deleted. So this rings a bell for me, but again, I don't have the time to actually look through all those traces every single day, all the time. So I can as well just define an evaluation task, which tries to identify such a scenario. One of the common approach to that is just write an evaluator prompt with criteria, which are telling to the evaluator what the tool contract is. So what is this tool supposed to do, and what information is it supposed to return back to the agent? So when this evaluator finds a mismatch, it would flag it as potentially compromised tool. So now if I were to look into the scores section again, I would be able to see that I have some traces which are showing tool contract integrity, contract break. So contract breach, probably a better English word, but whatever. I can again relate from the negative score to the specific span that was evaluated in a negative manner. I can go to the evaluations tab and I can easily see why did that evaluation task flag this one as contract break. And you would say that the explanation is something like the agent called findUser with whatever email whose contract specify it should return a user record. The response, however, came back with something delete through user ID, user billing. This shape matches the contract of delete user. So now this evaluator is giving you a hint that while you wanted to call find user, it seems like delete user was executed, which is kind of bad, right? So when you're trying to find the user, you really don't want to get this user deleted. So this is just another practical scenario that you should start implementing. So my last demo scenario, let me see which one I were planning to show you. Invisible execution failure. So even if you haven't had the opportunity to build agents, you've probably had the luck to interact with tools like ChatGPT, Gemini, or whatever. You know that those those assistants, AI assistants, would from time to time just hallucinate. They will give you information that is not grounded in any real data. What I want to show you today is how an agent might hallucinate something when the information is not grounded on anything coming from a tool call. So a tool call can be, for example, again, searching in my tickets or a database call. And this is actually super easy to happen in an actual environment, because what you will notice is that if you were to instruct that agent in a very directive way to always give you a response, right? So if I were to say, always give me a response, no matter what, the agent will hallucinate, even if the answer is not backed up by real data. So if we were to run this scenario, you already know that hopefully in a second, we're going to see a few traces inside the observability platform. And we now have our fresh trace, our last trace for the day inside the platform. And you would notice that there are a bunch of tool calls. So the agent appears to be trying to search through tickets. All of them are giving empty results. So from time to time, it keeps trying to call tools, but none of them returns any results. So it's empty data. It's a successful tool call. So if you are using APM, that would say 200 OK, right? The network worked, the HP protocol worked. So no data came from the tools. However, you can see that you still have an output. So users report they cannot log in at all when using Safari. Many customers experience a session timeout error. I have no idea how did the agent came up with this thing, but I know it's not real. Again, I don't have the time to look to every single trace, so I could create what we call a groundness evaluation task. So a groundness evaluation task is something which you check if the agent output is grounded in real data. And that's relatively simple to do. You again you instruct the evaluator by a prompt to make sure that whatever the agent returns as a final response is grounded in actual data coming from those tool calls. If I were to go to scores and check one of those groundness results, I would be able to see that something failed again. I would be able to see exactly what failed and the explanation about why it failed. So those were my demos. I ran quite a few stuff. I'm just wondering, it's all on my credit card. Okay, so it seems that it's not that bad. I've been generating some costs, but jokes aside, you already have those traces inside our platform, so we can just do some nice cost analytics around what's the most expensive app that you're running, what's the cost for your different models, and so on. So that if you ever doubt what would be the change in return of investment be if you swap a model, this is something that could give you a great indication.
And then before we get into key takeaways, I want to do a little director's cut here. I forgot to show this. Let's share my screen real fast. And I said I would talk about this. Yesterday we were doing a dry run. So again, this is like director's cut, like bloopers reel here. We had the both of us were like, we're gonna run this demo, hit the button, you put in the prompt, hit the button, and then the model just sat there. And if you look back at our observability traces, you could see yesterday. Look at these times here. We've got 51,000 milliseconds. It's like these agents were just taking forever. One even timed out. You can see it has errors. So that one just completely timed out there. It's still completed, but didn't complete in any meaningful way. But you can see the ramp up in the time that these were taking. This was all during our dry run yesterday from 11 o'clock until after we were done kind of testing this out. So it's really just interesting to see that data there and see it being captured. And you can see where that could be really useful, even if you're doing a stand up, let's say. You just did your development sprint and you're doing your stand up, and then like this thing is not working and it's taking forever. You can at least go back into your logs here and go, it was much faster yesterday. This is an isolated incident. So sorry the stand up didn't go well, but we'll try this again later. Before we put this into production, we might want to see why that latency does it and put some kind of fail safe in to go to a different provider or something if that's going to be an issue that can be reproduced, right? AI failures. It's more than just, did it pass or fail, right? Is the agent doing the work that it is supposed to be doing? I really liked your demos, Lubo, where it showed off, potential security alerts, where you can track things like phishing attempts and people trying to jailbreak your AI prompts and evaluate that to kind of throw up a red flag, and then you can take action on it. So I thought that was really important. I know cost is a big one for everybody because that's the big unknown right now. I think we're in that subsidized mode still, where a lot of the costs are, being paid by the vendors, hoping that you'll jump on board, and then these prices are going to get ratcheted up in the future. We're seeing a little bit of that now on the coding side, especially. So that's an interesting aspect of this. Any closing thoughts, Lubo, on additional takeaways here?
So what could I say? I saw a lot of you guys were still early in developing AI agents and so on. My advice for you would be pick whatever observability and evaluation platform you want, but add it early in your software development life cycle. What you will notice is that the agent that you built in the beginning, it's never going to work 100% okay once you deploy it in production. On the contrary, you would probably have to continuously observe, improve, evaluate, release a new version of your agent. And it's probably going to be much more often than what we are typically used to and accustomed to with traditional deterministic applications. So my advice for you is add whatever tool you want, even while you're still testing out stuff, prototyping stuff. It will save you a lot of trouble down the road. If you decide to work with our platform, we have a generous rate here. You can find the product on telerik.com and you can just start using it pretty easily. It's usually not going to take you more than 5 minutes to instrument an existing agent and receive your first trace inside the product.
Yeah, I love that you can add tags to all of the data, so you can figure out what, because a lot of times you're running things in development mode, and you still want to have that traceability there, because when you deploy it to production, you might get a different behavior for whatever reason, and then you can go back and compare, like this worked in development, but we're having this issue in production, and I can kind of hone in on what those issues are if I'm able to compare and filter and find those things.
Yeah. If you guys want to see some other typical agent failures and so on, feel free to download the leaflet that I wrote some time ago. Hopefully you find it interesting. It's completely for free. I think we're not even asking for your email, I hope. So yeah, that's it. If you want to continue talking with us, if you have any feedback on the product that we have created, if you have any questions on how to instrument your AI agent or what do you think you should be evaluating in your agent, we're quite active on Discord, so please feel free to join our Discord channel, reach out to me or just write in AI general, I guess, and you'll be happy to have a conversation with you. Anything else from you, Ed?
that QR code that we showed on all three screens goes to the same place. It's one click to find it all, and there's a couple resources there for you where you can grab the white paper, find the products, grab some demos, and yeah, catch up with us on Discord. All right, everybody, take care, and thank you for your time.